lesson 89, and we're learning about angles, but you have to learn about using diagonals so that we can figure out angles. I'll explain what I mean in just a second. So, everybody draw this on your paper. Then label it A, B, C, and D like that, okay? Now, a diagonal, what you're going to do is draw a diagonal between two non-adjacent angles. And a non-adjacent angles is basically like opposites. It's not on the same side, okay? So non-adjacent would be the opposite of A, which would be C. You see what I'm saying? So we're going to draw a diagonal right here, non-adjacent vertices, both of them, okay? Now, what do we know about triangles? Non-adjacent. Just like that. Okay? Alright. So, if I were to put a diagonal down here, does that help me? Yes, it does. And I want you to see why. This is a triangle, and this is a triangle. And what do we know about triangles?
They have three sides.
That they do have three sides. Perfect. This one is 180 degrees, and this one is 180 degrees. Does everybody see that and understand that? Okay? So, us just knowing information about triangles is going to help us in this. Okay, so now, let's look at a different shape. That's just kind of the beginning. I just wanted to show you. Okay? The next thing I want you to draw is a hexagon. Okay? And a hexagon has how many sides? 6. Hex, it's kind of like 6. 1, 2, 3, 4, 5, 6. Now, they said that this is a regular hexagon. What does that indicate?
They're all equal.
Very good. Regular means that they're all equal. Okay, now, because I'm human, I have imperfections. Therefore, this does not look like a regular hexagon. It looks kind of messed up, okay? So, everybody draw one of those, A through F on there, okay? Now, what you're going to do is you're just going to pick one vertices, okay? Does anybody remember what a vertices is?
The line.
Where they meet, basically the points, okay? So you're going to pick one of them. I'm just going to pick A because I start with A, okay? So this is the one I'm going to work with. And what you're going to do is you're going to draw from A to each non-adjacent, okay? So watch what I do. I'm going to go boom, boom, and boom. This is going to be very helpful in what we discover in just a minute. So, how much degrees does this entire thing make up? Let's figure it out. This triangle is
180.
180,
180.
180,
180.
180, and 180. 184 of them equals 720. Okay? So, each of these, and I'm only going to write the first one, is 180 degrees. Now, I'm going to take away my lines for just a minute. I want y'all to see what happens. So, because we know that each of these lines are regular, it also means that each of the angles are regular. Which means what? Regular. They all going to equal the same thing. So this angle is just the same as this angle, is just the same as this angle. Okay, every angle is the same because it's a regular hexagon. Okay, how do I figure out what each angle is if I know the total
Divided by 6.
is 720? Very good, Lane. So because we have 6 angles, and we know that the total inside, because we did diagonals, we broke it up equal to 720. So when I do that, I end up getting
120 degrees.
120 degrees. So each of these is going to equal 120. Okay? So everybody see how we did that? How we discovered it?
Yes.
Okay. That is learning how to do interior angles. Okay? And I'm going to go on and do a few more, and then we're going to learn about exterior angles, okay? So I'm going to leave this one up here for just a minute because I want to use it again, okay? But let's go on and do another problem, all right? So, for example, this is kind of like the one we drew in the very beginning, okay? Actually, it goes out just a tad bit more. There we go. Okay? And here's what it says. Draw a quadrilateral and one of its diagonals. So I'm going to draw a diagonal. Okay? So I drew a quadrilateral, four-sided shape, and then I drew one of its diagonals. Then it says, what is the sum of the measures? What is the sum of the measures of the interior angles of this quadrilateral? So they're saying, what do all of these equal together?
What do you mean? Like both triangles?
All the triangle, well, that's eventually what you're going to do, is we're going to try to figure out this triangle is how much?
180.
180. And this triangle is what?
180.
Okay, so what is the sum of the total inside? 360. Okay, so that was pretty easy. Okay, but that's some of the questions you're going to hear. All right, they're going to ask. All right, now, hopefully you remember that sum meant to add and get your answer. All right, now let's look at exterior angles. Okay, so if I decide to go for a walk and I start in this place and I were to walk around lane, around that outside, and then come to the right back to the spot I am, what does one full circle make in a degrees? 360. Very good for you to know. Okay, so one full circle is 360 degrees. If you don't already know that, write that down. It's very important. Now, there are two ways that you can figure out the answer to this, what I'm fixing to say. Okay, and what I draw actually looks really cool. Okay, so what you're going to do, let's say I'm at A, and I'm going towards B. Okay, so here I am, dun-ta-dun, dun-ta-dun, walking, walk, 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 walk. Okay, if I went straight, that's where it would go. Okay, so I would just keep going, but instead it turned.
Yeah, it does look cool.
Okay, I'm going to turn at B and start walking towards C. So I start walking, start walking, start walking. Okay, if I did not turn and I kept going, that's what it would look like. Okay, but I turned. So now I'm going to go towards D. Okay, and then towards E. And then towards F. Then towards A. Okay, and what you get is this cool looking like star, like almost like something you'd see on some kind of ninja show or something. It's like spinning. Okay, looks kind of cool. But what I want you to see is, what did I actually make just by going straight? I made exterior angles. Does everybody see?
Yeah.
That's an angle. This is an angle. So basically I'm saying, let's go from A to B, and then how much did I turn? Instead of keeping going straight, how much did I turn in my angle right here? Okay, so if I'm walking from A to B, and instead of keep going straight, I decided to turn. And I'm wanting to know how much degrees did I turn, is basically what I'm doing. So there are two ways to discover this. Okay, I know that one full circle equals 360 degrees. And if I have 1, 2, 3, 4, 5, 6 exterior angles, how much will each exterior angle be? No, that was when it was 720 on the inside. 60, because I have 360 total to go from A to B. I know it's going to be 360, okay? But how many times did I turn? 1, 2, 3, 4, 5, 6. I turned 6 times. So instead of walking continually and not turning at B, okay, I would have kept going straight, but this time I'm going to keep walking, and instead of keep walking straight, I'm going to turn. How much did I turn to then begin walking from B to C?
180.
60 degrees, okay? Each time I turned my body 60 degrees, okay? So that is how you determine the exterior angle. Does anybody else see another way I could have determined that?
I mean,
anyone?
yeah.
Gonna give you a hint. What does a straight line make 180 degrees. And if this portion of the inside is 120, then what would this be? 60. So you could have actually discovered the answer 60 two different ways. Okay? You could have saw this straight line and gone, okay, straight line equals 180. 120 minus 180 is 60. I got it. Or you could have said, okay, I have 6 exterior angles and a full circle is 360 on the outside, so therefore 360 divided by 6 different measures gets 60. Does everybody understand?
yes.
Sweet. Okay, that is lesson 89.
It's the next